Hello P6, this is Miss Claire and welcome to our Math 6 class. In this video, you will learn Chapter 3, 2D shapes and angles. In this chapter, you will learn 6 lessons. We have Lesson A, Identify, Describe, Classify and Sketch Quadrilaterals. Lesson B, Identify parts of a circle. Lesson C, Construct a circle. Lesson D, Find the area of a triangle. Lesson E, Classify, Estimate, Measure, and Draw angles. And Lesson F, Find angles in triangles. So let's start first with Lesson A, Identify, Describe, Classify, and Sketch Quadrilaterals. Are you familiar with quadrilaterals? Look at the picture here. Look at the wall of this house. Look at the shape. How many sides does this shape have? Do the sides of the shape have equal length? What kind of shape is this? It has 4 sides, right? During our class, we will discuss more about this one and we'll try to identify the name of this shape. So let's move on. Okay, let's start about quadrilaterals. Look at these pictures. Lily bought the following items. Parts of the items are made up of polygons with 4 sides. These polygons are called quadrilaterals. Remember P6, when we say polygons, they are 2D shapes that consist of only straight lines. But if the polygons consist of only 4 sides, they are called quadrilaterals. Let's check one by one. Look at the first picture. This is this is a square. How about this one? A rectangle. This one is a trapezium. How about this? This is a rhombus. How about the roof of this house? Yes, this is a parallelogram. And this one is a kite. Now let's discuss one by one. Let's start first about parallel lines. What are parallel lines? Easy is at a zebra crossing. She notices that the yellow stripes are always the same distance apart and they will never meet. These are called parallel lines. So lines, children, that goes together and it will never meet, they will never meet, they are called parallel lines. Look at these sketches. I have here 2 shapes with lines. We have line PQ, this one, and line is R. These 2 lines they will not meet. They are called parallel lines. This one is also parallel to another line BC. So, PQ is also parallel to line BC. Now, what are the other lines that are parallel here? So, if you know, you can share that during our class. Okay, next. What are the properties of a square? Okay, take a look. I have here some pictures of different squares, different sizes. These are squares. The square, children, they have opposite sides. Their opposite sides are parallel. This one, this side and this side are parallel, and the other opposite sides are also parallel. All sides of a square are all equal and they have 4 right angles. So our square has 4 right angles. And a square also has 4 lines of symmetry. We have 1, 2, we have on diagonal 3, and the other diagonal line 4. So again, a square has opposite sides that are parallel lines. All lines or all sides are equal. It has 4 right angles and it has 4 lines of symmetry. Next, we have a rectangle. Take a look. Opposite sides of rectangles are parallel and equal. This one, this side here on the top and here are parallel and they have the same size or the same length. This side also are also parallel. It has 4 right angles, just like a square, but it has only 2 lines of symmetry. Here, 1 and 2. Not like square, it has 4 lines of symmetry. Let's go to the next quadrilateral. We have a parallelogram. Look at this picture. Opposite sides of a parallelogram are parallel and equal, the same with a rectangle. This line here or side and this side are opposite sides and they are parallel. This side, the shorter sides, are also parallel lines. Remember, a parallelogram has no lines of symmetry and it has no right angles. Another quadrilateral is a rhombus. Okay, these are rhombuses. Look at the rhombus. Opposite sides are also parallel. So these two lines here are parallel and also these lines are also parallel. All the sides of a rhombus are all equal, just like a square. However, they don't have right angles. A rhombus also has two lines of symmetry here. One and the other side, two. Okay, now another quadrilateral, we have trapeziums and kites. Let's have trapezium first. These are trapeziums. A trapezium has only one pair of parallel lines. This one and two. The other sides, the other opposite sides or the other one pair of sides are not parallel. This one are not parallel. This one are parallel, this side and this side. This one also and this one. Next is a kite. Look at these shapes. The adjacent sides of a kite are equal. These are the adjacent sides. The sides that are connected, they have the same length here. And the other adjacent sides are also equal. A kite has only one line of symmetry here. When you cut here, both parts are the mirror image of the other. Okay. Remember also P6 that all quadrilaterals have two diagonals in each shape or polygon. Next, I have here 6 figures. We have figure A, B, C, D, E, and F. All you need to do, children, is to identify what quadrilateral are these. Now, let's decompose a parallelogram. Ron uses some toy blocks to make a parallelogram. Take a look at the picture. The parallelogram is decomposed into how many triangles? Can you find? Yes, there are 2 triangles and 1 rectangle. This is a triangle. There are 2 and 1 rectangle. Now, in what other ways can you decompose the parallelogram? If you have some answers, you can share that during our class. Now, let's sketch a rhombus or how to draw a rhombus. All you need to do is to draw a straight line, CD, this one. Next, draw a line segment point D to point A here and connect them. Such that CD and ED are equal or the same length. Then make sure that the angle they form is less than 90 degrees. Next, make a sketch line BC and it should be parallel to AD, this one. So, after that, you connect point A and B and that is now our rhombus. So, that's how to draw or sketch a rhombus. Now, I have here what we call tessellation. What are tessellation or what is a tessellation? A tessellation is when we cover a surface with a pattern or flat shapes with no overlaps or gaps. This one, just like this. Take a look. What have you observed on our tessellation? Ron says these are all quadrilateral tessellation. Is it correct? Okay. I have also here different kinds of tessellation. Take a look. So during our class, we will discuss more about tessellation. Now let's go to lesson B. Identify parts of a circle. Now look at here. AZ has a problem. How do I make a hole in the center of the circle? Can you help AZ? Okay. Cut out a circle, this circle, draw a line from one end of the circle to another end, cutting through the center of the circle. Draw another line from the center of the circle to any point on the circle. Name the lines and what is same and what is different. So try to draw or cut out a line or a circle, then make a line on the circle passing through the center. Okay? Next, let's study about circumference of a circle. What is a circumference of a circle? Tracy wants to replace her bicycle wheel. She measures the boundary of the wheel using a piece of string. The boundary of the wheel is called the circumference. This one. The string is here. This one. This is the string. So this is what we call the circumference of the circle. It means the distance around the circle. A circle is a set of points that are same distance from the center of the circle. Points here. So if you connect them, you can make the circumference of the circle. This one. If you connect all the points around. Okay, so that is what we call circumference of a circle. Now, let's study about the radius of a circle. Julie and Taz use a rope to measure the distance between them. The distance is 2 meters, and that is what we call radius. Radius, children, is the distance from the center of the circle to any point on the circle. From this point or from this center to this point, that is a radius. If more than one radius, we call it radii. Okay. Next, let's study about diameter of a circle. Taz moves away from the center to other side of the circle. They measure the distance between them. So if this is 2 and this is 2, this is already 4 meters. So this line here passing through the circle, the center, is what we call diameter. All diameters of a circle are equal and always pass through the center. If the line does not pass through the center of a circle, is it a diameter? For example, this one, is this a diameter? How about this? Is this a diameter? Okay, share your answers during our class. Now, let's study about the relationship between radius and diameter. The distance between Julie, this one, and the center of the circle is the same as the distance of Taz and the center of the circle. So all radii are equal and the diameter is twice as long as the radius as long as it passes through the center of the circle. So this is a radius, another radius here, so we have 2 radii. If they will pass through the center of the circle, that is a diameter. How about this one? This is a radius and this is a radius. Is this a diameter? Okay, how about this one? This is a radius, right? And I have another radius here. Is this a diameter? Remember, diameter is twice as long as the radius. But a diameter is from one point from the circle passing through the center, and it will make a straight line. Okay, remember. So if you know the answer, you can share that during our class. Okay, P6, that's all about lesson A of chapter 3. To identify, describe, classify, and sketch quadrilaterals. And lesson B, identify the parts of a circle. So during our class, I will discuss more about these 2 lessons. Thank you for watching P6, and I hope that you learned a lot in this video. Always remember to stay safe and healthy. God bless everyone, and have a great day.